The purpose of this video is to give you a little more clarity on how we're actually going to take data, what the method is for both of the experiments. So experiment A is how does acceleration depend on mass, and experiment B, how does acceleration depend on net force. So first let's look at experiment A. How does acceleration depend on mass? The basic idea in this experiment is to keep the net force constant. So you'll see that in these three trials this arrow is the same length, so constant net force, but we're changing the mass of the object, so we're going to increase that mass. For our setup, what does that look like? Our setup is a cart, a pulley, and a hanging object with a string connecting the hanging object and the cart. We need to keep the net force constant, and from reading about the lab, you should know that the net force on the system, okay, this whole thing is our object, well, not the pulley, but the cart and the hanging object, that total mass is our object, but the net force on that system is just the force of gravity on this hanging part. And so what we have to do to keep the net force constant is we have to keep this hanging thing constant. And that's going to be a 50-gram mass on top of a 5-gram mass hanger. So that is the net force we're keeping constant. So then for each trial, we need to change the system mass. So we have to change the mass of the system without changing this. So that's pretty straightforward. All we're going to do is add things on top of the cart. So for each trial, you'll add a different amount of mass onto the cart. Eventually you'll be adding on these real solid bars. That's what these are. So these are just different amounts of mass that you're going to add to the cart, and that will change the mass of the system while still keeping that net force constant. Experiment B, how does acceleration depend on net force? Now we're going to keep the mass of the system constant, represented by this block here. But we're going to increase the net force. We're going to start with a small force, then go to a larger force, and then even larger force. So how do we do that? This is the tricky one. We need to keep the system mass constant. And then for each trial, we need to change the net force. So remember what makes up the system mass? It's the cart plus everything on the cart plus everything hanging over here. That's the system mass. We have to keep that constant while somehow changing what's hanging over here. So here's how we do it. For each trial, we take some mass from on top of the cart and we move it and hang it over here. Do you see how that keeps the total mass of the system constant while allowing us to change the amount that is hanging? So it's a really clever way to do this. So you're going to start out to figure out the total system mass by just adding up what's on the cart plus the mass of the cart plus the mass of the hanger. That's your total system mass. That's our setup. For trial 1, you're going to take 10 grams off of the cart. So this little light gray one, see how now it's missing? It's not over here. Instead, it's over here. Trial 2, now we have 20 grams over here. So I put the little 10-gram one back on top of the cart because I need a total of 20 over here on top of the mass hanger. And then for the next trial now, we add another 10. So each time you're going to increase what's on the hanger by 10. But the important thing is that you're getting it from over here so that the total mass of the system stays constant.